Are you ready for some new information? If all the world's a stage and all the species merely players, then their exits and entrances can be found in the rock record. This poetic perspective highlights the continuous evolution and unfolding of life's history, a narrative that is etched into fossils and the layers of sediment in which they are found. A recent Virginia Tech analysis has now extended this narrative back to nearly 2 billion years ago, offering a more complete picture of life's origin, diversification, and extinction. Fossil evidence has charted evolutionary milestones over the past half-billion years, but researchers have now pushed this timeline even further back. The study, led by Virginia Tech geobiologist Shuhai Xiao, expands our understanding of ancient life to the Proterozoic eon, which spans 2,500 million to 539 million years ago. During this era, life forms were typically smaller and softer, such as sea sponges without mineral skeletons, which were less likely to leave fossil traces. This is the most comprehensive and up-to-date analysis of this period to date, said Xiao. And more importantly, we've used a graphic correlation program that allowed us to achieve greater temporal resolution. The team's findings provide a high-resolution analysis of the global diversity and evolution of Proterozoic life. This chart now offers valuable insights into how life's story played out during this vast period. During the Proterozoic eon, which lasted from about 2.5 billion to 541 million years ago, life on Earth was mostly simple and microscopic. Imagine tiny single-celled organisms like bacteria and algae swimming in the oceans. These early life forms played a huge role in shaping our planet. For example, they produced oxygen through photosynthesis, which gradually filled the atmosphere and made it possible for more complex life to develop later on. Around the middle of the Proterozoic, more advanced cells called eukaryotes appeared. These cells are the building blocks of all plants and animals today, featuring a nucleus and other specialized structures inside them. As the Proterozoic eon progressed, life started to get a bit more interesting. Towards the end of this time, some of these eukaryotic cells began to form simple multicellular organisms, laying the groundwork for the incredible diversity of life we see today. Fossils from this era show the first signs of tiny colonies of cells and simple sea creatures. Even though life was still mostly confined to the oceans, these early innovations set the stage for the explosion of life that would happen in the next eon, the Phanerozoic. For the next billion years, often called the boring billion, not much changed. Species evolved slowly, and diversity remained stable, with few new species emerging or old ones going extinct. This calm period eventually ended as Earth experienced dramatic changes. Shifts in the environment and evolution then brought a surge in diversity and set the stage for the development of the complex ecosystems we know today. Between 720 million and 635 million years ago, the planet experienced at least 2 severe ice ages, known as snowball Earth events. These global glaciations plunged Earth into an icy grip and reshaped life's trajectory. The ice ages were a major factor that reset the evolutionary path in terms of diversity and dynamics, Xiao explained. We see rapid turnover of eukaryotic species immediately after glaciation. That's a major finding. When the ice melted, evolutionary activity surged, marking the end of the boring billion and ushering in a more dynamic era of biodiversity. The study on eukaryotic evolution raises important questions about how environmental and evolutionary forces influence the development of life on Earth. For instance, why did eukaryotic evolution remain so slow and stable during the boring billion, a period marked by low species turnover? What triggered the rapid evolutionary changes after the snowball Earth events, when the planet thawed from extreme glaciation? Key factors under consideration include whether changes in climate and rising atmospheric oxygen levels played a role in accelerating evolution. Additionally, scientists wonder whether competition and interactions among organisms created an evolutionary arms race that drove species to evolve faster. According to Xiao, the team's findings create a foundation for future research. By analyzing the patterns revealed in this study, scientists can delve deeper into the complex relationship between Earth's changing environments and the evolution of life. The study of Proterozoic life enhances our understanding of how early eukaryotes, the ancestors of modern animals, plants, and fungi, evolved. The research also reveals how living organisms and Earth's environment influenced each other in complex and interconnected ways over billions of years. By extending the timeline of life's history, this research gives scientists a detailed framework to explore unanswered questions about Earth's ancient past. It helps us see how events from billions of years ago shaped the planet and life as we know it today. For more on this story, find a link to the article below on Earth.com in the description.